here we go. We're going to be graphing. So today you're actually going to need your graphing calculator. All right, so if you have that, please get it out, have it handy and ready for you. Today we're going to talk about connect the roots of a quadratic equation with a graph of a function. We use technology to find those roots. All right. Remember, quadratic equations will have any possibility of 0, 1, or 2 real zeros. Okay, if the function has no zeros on the graph will not cross the x-axis and the roots are imaginary. So this would be an example of that. Okay, so I'm going to so I'm using my finger this time. No real zeros, imaginary. So if it's hard to read, I apologize. But it could actually end up being better, knowing me. Or you could have something like this, where it's flipped and we have a maximum. That's also another possibility. Okay. We also, and our discriminant here, our discriminant is a negative. The negative. All right. When during this case. Okay. We could also have the possibility has one real zero will touch the x-axis and we're called a double root. Okay. Well, here's an example of that here. Okay. There's a bounce. One real zero. Double. And double root members like x plus 3 or x minus 3, x minus 3. All right, and your determinant is equal to 0 in that case. Okay. There's also the possibility that we have 2 real zeros and our parabola crosses the x-axis twice. Okay, just like here, or it could be up like that. Okay. In this case, we have, just like we said, we have 2 real zeros, 2 real zeros. Discriminant is positive. All right. For this video, okay, there are step-by-step instructions on how to graph a parabola. All right, using your calculator. I'm going to go through this with you as well. Okay, with our first couple. All right, and then I'm going to have you do the third one by yourself. Okay. First of all, when graphing or before graphing, I want to make sure that my function, my quadratic, is in standard form, which this is. All right, which this is. So I'm going to go to my y equals. If you have a plot that's highlighted, make sure you turn that off and just go up there and select it. My first function is 25x to the second minus 20x plus 3. All right. So I'm going to go to zoom and go down to number 9 because I don't know if I've been graphing trig functions lately or what's been going on. Not number 9. What am I thinking? Zoom 6. My fault. Zoom 6. I don't know what's been going on lately with my calculator. Okay, so I went zoom 6, and now it's really hard to see. So I might have to adjust my window. Now here's the deal. There is no necessarily set number you should adjust your window. It's kind of a guess and check game. I'm going to go -5 to 5. Keep the scale the same. I think I can get away with 0. And then let's go to 15. Just numbers. Guessing and checking. Let's see how that works. All right, maybe I'll go to negative. Maybe I'll shrink this up a little bit more now. All right, let's go -4 to 5. Maybe the minimum is -2. See how that looks. All right, still tough to see. I'm going to go from -1 to 2 for my x values. Again, the window is more of a guess and check game. All right, just so I could see. Look at, oh, there we go. Now I see it. Okay, so I want to adjust my window. All right, press zoom and select 6 for standard. If that doesn't fix it, try adjusting your window, which we did. Okay, so now we need to go to second, then trace. All right, so I'm going to press second, trace, and go to the calc. Then go to the calc features and select 0. So I'm in the calculate feature, and I want to select 0. Okay, so you'll see it talks about this Spider-Man. So I have this little Spider-Man here that's highlighted. All right, I want to get my Spider-Man on the left side of my root. So the root that I'm looking for, I'm going to do my first one as my left root. So I want this Spider-Man to be on the left side of my function. So it says left bound, so that means the spider should be on the left. Press enter. Now it says right bound, so I want my function to my Spider-Man to be on the right of where I think that actual 0 is. All right. And then it says guess, and I want my Spider-Man to land close to my 0. Okay. And press enter. And my 0 is 0.2, comma 0. So that's my first root. 0.2, 0. Okay. I have to repeat the same process to define this other root, which is right here. So I'm going to press second, trace, calculate, and I want 0, so I'm going to press 2. I want the left side. Here's my root. I'll move this Spider-Man to the left side. This should actually be reviewed. Definitely do this in AAA. Press enter. I want it to be now on the right of my root or above it. Press enter and guess it. I want to get it close to my root as possible. And press enter. So 0.6. Wow. Fun stuff. Again, first thing we need to do is make sure our function is standard form. So I'll move everything to the side with the x squared. So my x squared is positive. I like positive x squareds. All right, let's try that again. 16x squared minus 44x plus 42 equals 0. All right, here we go. 16 plus 42. Okay, press zoom, and I'm going to go back to standard just to see how that does. Not really great. Why? Because, well, first of all, my y-intercept is positive 42. So I'm going to need to adjust. Let's see. Let's say my y minimum is, my y max is 50. My y min, I'm just going to put it 0. See if that adjusts it. Okay, here we go. We're starting to see something. All right, let's adjust. Well, let's look at this graph. Is it going to touch? No, this graph does not cross our axis. So after seeing that, I would say no real zeros. And if this were the case on a quiz or test and said find all the zeros and you did it graphically and you got no real zeros, but, well, then you would have to find the imaginary roots. All right, you have to find our imaginary zeros. Okay, so on a test or a quiz, we'd actually do that, but I'm just going to keep going. Here we go. Because let's save some time. Last one, 2x squared plus 4x minus 5. So this one might get away with zoom standard. We'll see. Oh, buckets. Look at that. All right. Let's see. Here we go. Second, trace zeros. All right. Move the Spider-Man to the left side of my root. All right. So it's on the left or the upper side of this root. Press enter. Then move it to the right side or below it. Press enter. Then try to get it as close as possible. Press enter. Enter. So we got negative 2.871, comma 0. Run to 3 decimal places when you have to. Second trace, let's do that again. 0. All right, move the Spider-Man to the left. To the left side, press enter. Move it to the right side, press enter. Move it on it. Press enter. 0.871, comma 0. Wow. Those are our roots, and that's how you find those roots graphically. Just to review, all right, I could have no real zeros, okay, in which I have imaginary roots, all right. I could have one real zero, which a double root, my discriminant is 0, and I could have 2 zeros where my discriminant is positive. Okay, that is graphing. So much fun.